Dr. Knag!
Dr. Bilo! Now you're done by driving, aren't you?
Blenkerschloss. Dr. Knag!
Listen, I have the key.
Where are we today? No, Dr. Knag, where are we today?
Dr. Bilo, we are in TU Munich. It was quite a ride. Well, you were driving a lot. We're going to meet Professor Thomas Auer. He's the climate design or climate engineering professor at the TU Munich Faculty of Architecture. And in parallel, he's one of the central persons at Transsolar Climate Engineering, a quite famous climate design company.
Actually, he is my favorite climate designer.
Well, not only yours.
Happy to see him today.
Yes.
Curious about it.
Let's go. Ports.
Auto kaputt.
Windows, doors, other things we need. All right, Thomas, let's talk about solid and solid/massive facades, layout and function. So how is such a facade qua layout?
I mean, it's just one block. It's like stones attached to each other. There are no layers. It's just one layer, which is like massive stone.
Okay, so it's a monolithic block which builds the entire wall as a system. And the function, it serves the typical functions of a facade.
All functions, it separates from inside to outside in terms of weather, etc., etc. It's all functions. However, I mean, this is a heritage facade. This one is something like 100-ish years old. Today it would look a bit different, but anyway, it's still the same.
Okay. What are the typical materials for such kind of facades? You said this is a heritage, this is natural stone. Is it inside natural stone as well? That's the one question. And then the other question, what different materials, concrete, clay, bricks, would we be able to use?
I mean, you're coming from construction. You told me it's probably brick inside. It's the natural stone more to the outside where it's more representative, but it's still kind of monolithic. It's one stone, it's one material. Doesn't change its function in terms of layers. But today we would use concrete, we would use brick. What else? Clay. Yeah, clay is pretty contemporary now. Pretty en vogue, but when we think of massive, those are the materials.
So we see the natural stone as it is here, and knowing the age of the building, I thought it's eventually brick. So that's a very small brick, I know. That would be, say, the brick alternative, and then the other alternative you would be able to build such a facade would be concrete. You tried the concrete versus the stone.
You what?
Clock.
Yeah. Look at this. I mean, here you see the concrete fails, the natural stone remains nothing. So you see how strong this material is. This is why it lasts so long. This is why it's here for more than 100 years, no renovation.
As you said, I'm the guy from construction, you're the guy from climate design. What's your favorite of this kind of construction? Why do you like it?
It's heavy, and this thermal mass, how we call it, creates a very stable indoor climate. So it creates a robust environment. So this is how we call it.
When I look at this structure, it's nearly meter thick. That's an enormous amount of material versus other materials. Think about the IGU glass units, 3 to 3 centimeters. Think about cavity structures, layered systems of insulation. How does this, say, thermally work?
Yeah, I mean, this meter thick certainly helps, particularly in summer. Winter, it's a different story. Therefore, we would use other materials now and for winter time for insulation purposes. But in summer, it works very well. But however, I mean, you are absolutely right. The biggest disadvantage is we lose land, property, real estate. So there are lots of things we have to discuss, material use. And
No. We don't talk about commercial in this situation. We talk about construction. That's a different story. Openings. We need to have openings in a solid facade due to the need of ventilation and light. How are these openings made?
I mean, you put a window and then you have an internal layout which determines where you need light, where you need to have views to the outside, where you need to get access to natural ventilation. And then this determines where you have your windows.
And the position of the window is now right in the middle of this solid facade?
It's in the middle. I mean, that's a good discussion we have. Nowadays, people come with these solid facades again, thick walls, and then there's a discussion whether the window should be on the inside. Because if it's on the inside, this thick facade starts to shade the window. You get rid of shading devices, of movable shading devices. In terms of thermal performance, the window always creates a cold bridge. And so where do you want to have this cold bridge? So it's for winter purposes, you want to move it out. For summer purposes, you want to move it in. So the center is a compromise.
Okay, and now the opening needs to be made. And as we see, this is a natural stone facade. We see these arches. How do they function?
I mean, you see the arches up there. This is different from what we would do today with concrete. It was natural stone. There was no beam. So if you don't have a beam, then you need to. This is load bearing. You need to deal with the structural loads. That's why you create this arch so that you kind of redirect the structural loads aside of the window. So that's how you see those kind of arches.
And that happens with the natural stone as well as with the bricks. Same setup as we see it.
Yeah, same idea, same setup, also on the inside with the bricks. This is a load-bearing facade. It's not like the IGU you mentioned, where we have, let's say, inside the structure and the curtain wall. It's just attached to the structure. It's not load-bearing. This is a load-bearing facade. All the loads coming from above are carried by these massive walls. And then where you have a window, you need to get the loads onto the sides.
And we just continue. And how would you do that in concrete?
How would you do it in concrete? You have reinforcement in concrete. You put steel into the concrete, and the steel takes over the loads, the tension. Concrete can't deal with tension, so that's why you have the steel, and then you would have a horizontal window.
And if I would do a concrete opening like this without steel, I would end up in the same kind of arches.
You end up with the same arch. That's how it works.
Thank you. We stop here.
Yeah.
Perfect.